So the first thing that we want to do is we want to find the general derivative of g. So g prime of x equals, to find the derivative of e to the ax, we have to take the derivative of a to the x and bring that to the front of e to the ax. And so the derivative of a to the x would just be a, because you just take the constant out of it, because x is just x, it's not x squared or x cubed. So it's just like if the derivative of 2x would be 2. You're just taking the constant and bringing it over. So this would be, you would bring the a to the front, a times e to the ax, plus the derivative of f of x would just be f prime of x. So that's the general derivative solution. We can't really do anything more with this to find the general solution because a is unknown and we don't know f prime of x. But to find the next part, g prime of 0, we know what f prime of 0 is because it's a given. And we can plug in 0 for x here. So it equals a times e to the a times 0 plus f prime of 0, which we will plug in the actual value for f prime of 0 in the next step. So here, okay. And a times 0 would just be 0, so a times e to the 0 plus f prime of 0 is -4, so plus -4. And e to the 0, any number to the 0 is just 1, so equals a times 1 minus 4, and a times 1 is a, and so our final answer for this part of a is a minus 4. Okay, stop. So g double prime of x equals, to find the derivative of a times e to the a to the x, again we just take the derivative of the a to the x, not a to the x, a to a times x, so we would bring the a to the front again, so a squared e to the ax, and the derivative of f prime of x is just f double prime of x, so plus f double prime of x. That's the general solution for the second derivative, and now we take g double prime of 0. And we just plug in the 0 for all the x's, so a squared e times a to the a times 0 plus f double prime of 0. And f double prime of 0 is a given, so we can plug that in our next step. This equals a squared e times a to the 0 is, a times 0 is 0, and then plus f double prime of 0 equals 3 from the given. And we can cross out this because e to the 0 is 1, and 1 times a squared equals a squared, and we have a squared plus 3. And so that was, now we are done with part A, and we can move on to part B. We have to find h prime of x and write an equation for the line tangent to the graph of h at x equals 0. So the first step would be finding the general derivative of h of x. So h prime of x would be, here since h of x isn't adding up to different terms, it's a compound term, so we have to use the product rule to find the derivative. So first, since this is one term and this is another term, we would find the derivative of the first term and times it by the second term, and then add that to the first term times the derivative of the second term. So first we will leave cosine of kx as it is, and then we will multiply that, times that with f prime of x, because that's the derivative of f of x. And then we would add that to the derivative of cosine of kx is, we would bring the k to the front because it's the derivative of the inside function. So k is at the front. And then the derivative of cosine is actually negative sine x. So we will add a negative here. And then it's sine, and then the function on the inside would still stay the same, so of kx. And then we have to multiply that with the second part of h of x, f of x. And now we can plug in the 0 to find the specific derivative. H prime of 0 equals cosine of k times 0 would be 0, so cosine of 0. And then we multiply that with f prime of 0, which we can see from the given is negative 4. And then since it's plus a negative, we're just going to bring that negative out front. And k sine of k times 0, again, would be 0. So sine of 0, and then f of 0 is 2 from the given data. So now to find cosine of 0 and sine of 0, to find cosine of 0 and sine of 0, it would be on a graph of the unit circle. 0 would be right here because it's going around, and then cosine of 0, cosine is just the x value, and because it's a unit circle, cosine would be 1. Cosine of 0 equals 1. And sine of 0, because it's on the x-axis, it has no y value because it's not up or down. So sine of 0 would just be 0. Now we can plug those values back in. Cosine of 0 is 1, so 1 times negative 4 minus, since sine of 0 equals 0, it just cancels out all the other equation components of that term. So we get negative 4 minus 0, which equals negative 4. So that gives us the slope of the equation h at point 0, because the derivative is the slope that you're finding. So we will use this as m in the next part of part B. And now to fully solve this equation, we need to know the point on the original graph h. We need to know the y value of when x equals 0. So we would find h of 0. So we would plug in 0 for x. So k times 0, any constant times 0 is 0. So it would be cosine of 0 times f of 0. F of 0. So we know from earlier that on a unit circle at 0, cosine would be 1 because cosine is the x value, so it's out 1 because it's on a unit circle. So h of 0 equals 1 times from the given f of 0 is 2. So this is 2. So the coordinates that we have to work with are 0, 2. Now we can plug this back into the solution. So 2 equals negative 4 times 0 is 0 plus b. So 0 cancels and b equals 2. And now we just plug the b back into our y equals mx plus b, and we have y equals negative 4x plus 2. So now we have solved all the questions from number 6 of the 2006 FRQ. And for more practice in our calculus textbook, you can go to section 3.2 for more practice in derivatives, and number 43 to 45 in section 3.2 provide practice with plugging in givens. Thank you.